Our next definition is negative of a linear functional. So what is the negative of any linear functional? We will study that. So definition of negative of a linear functional. Now what is that? So here I am writing the definition of negative of linear functional. Now we are supposing that V is any vector space over the field F. Now we are again supposing that F be a linear functional on this V. Then the negative of linear functional of F is defined by minus f of u is equal to minus f of u. This is the definition of negative of linear functional. So minus of f of u is equal to minus f of u. Now we will prove that the negative of a linear functional is a linear functional. So here we have to prove that the negative of linear functional is also linear functional. So to prove this, solution, again let f as any mapping from V to F be a linear functional. Then the negative of f is defined by minus f of u is equal to minus f of u for all u belongs to vector space V. Therefore, we can say that minus f is a function from V into F. So it is obvious that f is a functional. Now to prove that it is a linear functional, we are selecting any two elements, u and v belongs to V and alpha beta belongs to F. If u and v belongs to V, then we know that minus of f of u is equal to minus f of u and minus of f of v is equal to minus of f of v. So we are taking left hand side as minus of f of alpha u plus beta v is equal to minus, see it is defined that this can be written as f of alpha u plus beta v. If we see this minus as a scalar, so if I am writing minus as minus 1 into f of alpha u plus beta, then we know that our f is a linear functional. So if f is linear functional, then I can write this is nothing but minus f of alpha u plus beta f of v. Now this can be written as minus alpha f of u plus minus minus beta f of v. But this is nothing but, again, alpha and minus both are scalars, so commutative law holds in scalars, or we can say commutative law hold in field. So I can write this as alpha minus f of u plus beta minus f of v. So from here we can say that minus of f alpha u plus beta v is equal to alpha minus of f of u plus beta minus of f of v. Therefore, we can say that negative of a linear functional is a linear functional. Therefore, minus f is a linear functional. Now we have a theorem. So theorem, let f be a linear functional on a vector space Vf. Then first one is f of 0 is equal to 0, and second one we have f of minus u is nothing but minus f of u for all u belongs to v. So we have to prove this. So solution, or we can say proof. Here f is a linear functional on a vector space Vf. Let u belongs to v. Then we can say that if u belongs to v, then obviously f of u belongs to this field f. Now for the first part, we have f of u plus 0 is nothing but f of u. Since we know that f is filled and every field contains 0 element, so if 0 belongs to f, then f of u plus 0 is always f of u. Now I can write this f of u plus 0, since 0 plus u is nothing but u only. Now here my f is linear, so I can write this as f of u plus f of 0, since f is linear functional. So I can write this. Now here we are getting f of u plus 0 as f of u plus f of 0. So if I cancel, if I use left cancellation law, then I will get answer as 0 is equal to f of 0 by left cancellation law for addition in f. So using left cancellation law, we get 0 is equal to f of u, that is 0 equal to f of 0, that is f of 0 is equal to 0. So this is the first part of the theorem. Now for the second one, we have f of u plus minus u is equal to f of u plus f of minus u. I can write this since my f is linear functional. Now this remain as it is, but from this I can say that this is equal to f of minus u, and this become my u plus minus u is nothing but 0 for all u belongs to u, for all u belongs to v. So f of 0 is nothing but 0, because we have proven the first part. So we can use our first property here, f of u plus f of minus u. Now if I will, here we have f of 0 is equal to f of u plus f of minus u, because u plus minus u is equal to 0. Here we have proved in the first part that f of 0 is equal to 0. So from first part by 1 we can write that f of 0 is equal to 0. Now I have to take additive inverse of f of u. So on taking additive inverse of f of u on left hand side, I am getting answer as minus f of u plus 0 is equal to minus f of u plus f of u. So this becomes 0 plus f of minus u. Now 0 plus f of minus u is nothing but f of minus u only. So I'm getting answer as f of minus u is equal to minus of f of u. Therefore, we get the required result which is asked in the question. So this is the theorem based on linear functional.